And greetings and welcome, friends. We're looking at 2009, problem 21 from the NECAP test. Back in the day, our students scored 0.3 points on this, and the state scored 0.6. And my door just opened on its own. It's always the sneakiest door. That's fine, though. So here, let's look at this problem. It actually says no calculator, and a moment ago we answered this question without it, but we'll talk about it, and then I'm actually going to show you what these graphs would look like. Let's read the problem. I'm getting ahead of myself. Coach Murphy records the weight of each person that tries out for the football team and the number of push-ups each person completes in 1 minute. This table shows the data. Coach Murphy wants to display these data, that's right, data is a plural word, it's so weird, using a bar graph, a line graph, or a scatter plot. Use mathematical reasoning to explain which of these data displays is most appropriate. Should that be the word are? Which of these displays are most appropriate? Man, I'm so confused. Are most appropriate for Coach Murphy to use. So let's actually talk about what these are. So a bar graph is when you have a height representing each of your things, right? That's what a bar graph would kind of look like, something of that effect. A line graph is kind of like, would be where each, let me draw it in a darker color, each point is connected by a line, would be kind of like that. However, I have two sets of data technically, weight and pounds, so we'd end up having something like this, where it like, what? Oh, yeah, you're right. Yeah, weight and push-ups, not weight in pounds. That doesn't make any sense. And a scatter plot, in case you're wondering about the vocabulary of that, is when you have a series of points where the x-coordinate of the point, say, would represent maybe the weight, and the y-coordinate of the point represents the number of push-ups. And each point represents an individual student. Okay, so looking at these, our students had agreed that a scatter plot would be the best one for relating that data, and I agree with them. My logic is that each point representing an individual student, you can kind of see that student's relationship to the rest of the group, and also you can maybe figure out a trend between all of them. You know, I assume perhaps doing a push-up if you're heavier maybe is harder. That would seem to make sense to me. But let's actually look at this. I drew this up in Excel. So here's that data listed as a bar graph. All right, and so we end up having a lot of different bars. So we can see the number of push-ups here, and you can kind of see, like, you know, the kids that have more push-ups, I suppose. So it does display the data. And it's got the side-by-side bars represents that first student's weight and then that first student's push-ups, right? So it does display the information, but it's a little bit cluttered. I mean, you could perhaps, let's see if I snapshot this. You could perhaps figure out what threshold, if you want to just base it on number of push-ups. Well, I guess you know, maybe you have a cutoff line for both, because you do want certain linebackers, you know. So let's say you only want football players that are at least 180 pounds or something like that. So then you know to eliminate some. And then you also only want kids that can do a certain number of push-ups, you know. And then you would eliminate the ones that didn't fit into either of those categories. You could kind of figure something out, but it's not necessarily the best representation of the data. So here's a line graph. So for one student, they actually have two locations, right? Kind of like the bar graph. And the line graph is usually really good at showing trends between consecutive points, but there's no reason to show the trend between student 1's weight and student 2's weight in that way. Like, there would be no value in necessarily connecting those things. Like, seeing this spike doesn't actually mean anything significant to me, because the only reason that spike exists right here is because that student's data happened to be adjacent to a student that had lower data, right? If I had this student's value next to this student's value, it wouldn't have seemed as dramatic. So those individual spikes aren't actually that interesting to us. They're not communicating anything extra. And then if we look at a scatter plot, you can actually see each individual student, and I'll show you how you could actually, let's see, there we go, show you how we could actually translate this information into something useful for the coach, similar to kind of having those thresholds. Well, with a scatter plot, so it looks like x-axis happens to be the weight, and the y-axis is the push-ups, PU. And with this data, you could kind of figure out some sort of a trend line, or maybe the threshold actually would be more like that. So you could have a trend line to figure out, you know, where people would typically lie. But maybe you have some sort of threshold that's like this, where you only want students that can do a certain number of push-ups, you know, but also have a certain weight or something like that. Or I guess you could kind of do it horizontally and vertically, maybe would make the more sense. So the students in maybe this category would be the ones that you'd really want to target. And then these ones maybe you then still have on your team, but then you could give them immediate advice, like, okay, all of you guys need to start doing more push-ups. All of you guys start eating more Frosted Flakes. You guys join the chess club, maybe. I don't know. Who knows? Who knows? But yeah, I agree. Scatterplot's the best way to present that information, because each point represents a student, and you can see their value in both of those directions or dimensions simultaneously. Yeah, so I think it's pretty good. So anyways, thanks for watching, internet friends. Bye-bye.